In terms of reactivity, the carbonyl carbon is electrophilic. It acts as an electrophile, meaning it carries positive character. So we've seen several electrophiles already, but let's look specifically at the carbonyl. And I'll just look at a ketone here. And let's even compare that to an organochloride. And let me draw in the hydrogen here as well. So we know that in the organochloride, there's a dipole here toward the halogen. That makes the halogen partially negative, the carbon partially positive, and therefore the carbon is electrophilic. It's a very similar scenario with carbonyls. So we have a dipole pointing toward the oxygen. That makes the oxygen partially negative, the carbonyl carbon partially positive, and it makes that carbon very electrophilic. Now, we know that electrophiles are attracted to nucleophiles. So let's think about adding a nucleophile to these. So a nucleophile will have something with a lone pair, and I'll even put a negative charge. Now, in the case of an organochloride, if we add a nucleophile to that electrophilic carbon, that carbon already has 4 bonds. So when I add the nucleophile to the carbon, that's going to violate carbon's octet. So we simultaneously lose our leaving group, the chlorine. Because remember, we can't violate carbon's octet. Now, in the case of the carbonyl, it's a little different because we have that pi bond. Now, yes, this carbon does have 4 bonds right now. It has an octet. It's happy as is. But with it being electrophilic, it can accept that bond from the nucleophile. But rather than actually losing something like a leaving group, what happens is this pi bond will just go up onto the oxygen as a new lone pair. So the oxygen already started out with 2 lone pairs. And when we add that nucleophile to it, now that oxygen has a 3rd lone pair and a negative charge. So it's very similar to what's going on down here, except because you have the double bond, the oxygen doesn't leave. Now, what we're going to see in this chapter are a couple different nucleophiles. We're going to see hydride as a nucleophile. We're also going to see carbon as a nucleophile, and that's going to be something like CH3-, or we'll have various different organometallic species.